Hello, I am Sindhu Johnson, Associate Editor at the Journal of Rheumatology, and I'm pleased to welcome you to my interview with two of the authors of an important and interesting article from the May 2026 edition of the Journal of Rheumatology. Today, I will be speaking with Doctors Ayla and Shervin Asasi from the Division of Rheumatology at UT Health Houston in Houston, Texas, in the United States. They will discuss their featured article titled Association of Type 3 and Type 6 Collagen Neoepitopes with Disease Severity in Systemic Sclerosis. Thank you both for taking the time to speak with me and our listeners about the findings of your work.
Good morning.
Good morning. Thank you for the invitation.
So, first question. The project used serum samples collected in the Conquer cohort. Can you tell us a little bit about the Conquer cohort?
Sure. CONQUER is an observational cohort study of patients with systemic sclerosis conducted across 19 specialized centers in the United States. All participants meet the ACR EULAR classification criteria for systemic sclerosis and have a disease duration less than 5 years. Patients are followed at 6-month intervals. The study is sponsored by the Scardama Research Foundation, with the Data Coordinating Center being located at the University of Utah. A distinguishing feature of this cohort is that it also has a centralized biorepository, which is located in our divisional laboratories at UT Health Houston. This supports both translational and clinical research in this nationwide cohort. In the present study, we capitalized on this resource and we evaluated baseline and available 6-month samples from 222 patients enrolled in CONQUER cohort. We believe the multi-center design of this study enhances the generalizabilities of this research findings.
Thank you. So in this project, collagen neoepitopes were measured and their changes were correlated with changes in the levels of inflammatory cytokines. Could you please tell us which serum proteins were measured in this project?
Sure. So we selected collagen neoepitopes because fibrosis is one of the central hallmarks of systemic sclerosis. And we know that collagen is the major component of extracellular matrix deposited during fibrosis. And the reason we focused on type 3 and type 6 collagen is because these collagen subtypes are expressed in tissues that are like majorly affected in systemic sclerosis, namely skin and lungs. And prior studies, including a study from our group, like demonstrated that increased expression of these collagen genes um, are found in scleroderma skin. And we also think that these biomarkers reflect dynamic extracellular matrix remodeling, and collagen pro-C3 and pro-C6 represent formation, collagen formation, and C3M and C6M reflect collagen degradation. And evaluating both formation and degradation products allowed us to better assess the balance between matrix deposition and breakdown, which we think is central to fibrosis pathogenesis. And these biomarkers were also previously shown to be correlated with clinical features in other fibrotic diseases, but we didn't really have longitudinal data in systemic sclerosis, which kind of motivated us to study these biomarkers in our cohort. And in addition to these like collagen biomarkers, we also measured CRP, ILC, interleukin 6, and composite score of interferon-inducible chemokines. And we were wondering if these were also correlated with these collagen biomarkers.
Interesting. So I'd like to pick up on that. You observed correlations between collagen neoepitopes and the severity of skin and interstitial lung disease, which were consistent with prior literature. Can you tell us about those?
Yeah, of course. So we observed that collagen formation biomarkers, which are ProC3 and ProC6, were associated more strongly with skin fibrosis severity. And both of these biomarkers were elevated in patients with diffuse cutaneous disease, and they were also positively correlated with MRSS, which is in line with previous studies showing showing increased collagen formation biomarkers in diffuse systemic sclerosis. We also found that anti-RNA polymerase 3 positive patients had higher ProC3 and ProC6 levels, so they had higher formation biomarkers, which is biologically plausible given the aggressive early skin fibrosis in this subgroup of patients. In contrast, if you look at our collagen degradation biomarkers, they were more closely related with lung involvement and lung severity. So C6M was significantly higher in patients with ILD, and both C3M and C6M showed negative correlations with FVC percent predicted, suggesting higher collagen degradation activity in patients with more severe lung disease. And similar findings, particularly regarding C6M and ILD, had also been reported in previous scleroderma studies as well. So overall, our results support the concept that collagen formation markers may better reflect skin fibrosis, whereas degradation biomarkers may better capture lung involvement.
Interesting. Now, I thought that the Pro-C3 showed a somewhat paradoxical relationship. Higher levels were correlated with worse skin disease cross-sectionally, but predicted improvement in the modified Rodin skin score over time. So how should clinicians and researchers interpret these phase-dependent behavior, especially in early disease?
Yeah, th thank you for this interesting question. I also think this is like one of the most interesting findings of our study because I think, highlights the importance of disease phase when interpreting these fibrosis biomarkers. Cross-sectionally, higher ProC3 levels were associated with higher MRSS, which makes biological sense since ProC3 reflects active type 3 collagen formation and therefore more active fibrogenesis. However, longitudinally, higher baseline ProC3 levels paradoxically predicted lower subsequent MRSS over time. And we think this is probably because of the natural history of systemic sclerosis. Patients with most active and rapidly progressive skin fibrosis may have very high collagen formation early in the disease course before reaching their peak MRSS score, resulting in elevated ProC3 levels at baseline. However, those same patients may also reach their peak skin involvement earlier and subsequently enter a phase of softening or regression of skin thickening during follow-up. Therefore, early in the disease, a high ProC3 level may not simply represent worse feature fibrosis, but it is probably a marker of highly active fibrotic phase that is already near its peak. And clinically, this suggests that collagen biomarkers such as ProC3 should be interpreted within the context of disease duration and disease phase, like rather than a static prognostic marker. It also emphasizes the importance of longitudinal studies in systemic sclerosis because biomarkers may have different implications depending on where the patient is along the disease trajectory.
Well, you make a good point. So, although several of the biomarkers correlated with disease severity cross-sectionally, most did not perform well as prognostic or dynamic biomarkers. What do you think this tells us about the challenges of developing serum biomarkers that truly predict or track disease progression in systemic sclerosis?
Sure. Prognostic biomarkers are basically biological markers that predict natural history of disease, whereas dynamic biomarkers are biological markers whose change predicts a meaningful clinical outcome. In the current study for prognostic biomarkers, we examined whether baseline levels of collagen neoepitopes predicted the longitudinal course of skin score among patients with diffuse systemic sclerosis or predicted longitudinal follow-up lung volume measurements as captured by forced vital capacity in patients with interstitial lung disease. All analyses were adjusted for mycophenolate use, except for the ProC3 association with longitudinal skin score measurements discussed by Ali. There was no other significant associations. For dynamic biomarkers, we examine whether the percent change in collagen neoepitopes from baseline to 6-month visit predicted longitudinal follow-up skin score or longitudinal follow-up lung volumes. None of the collagen neoepitopes showed predictive significance. As a whole, the fact that systemic sclerosis is a multi-compartment disease where fibrosis occurring in multiple organs, at least in two prominently affected organs, skin and lung, and where the course of lung and skin involvement can be divergent. We believe it's hard for a general fibrotic-based prognostic or dynamic marker to perform well for prognostication in a multi-compartment disease such as systemic sclerosis.
Good points. So, Shervin, your work highlights correlations between collagen turnover markers and inflammatory pathways, including CRP, IL-6, and interferon-inducible proteins. How does this work reinforce or potentially reshape our current understanding of the inflammation-fibrosis axis in systemic sclerosis?
I believe that's one of the most interesting findings of this study because we actually had longitudinal measurements of both collagen neoepitopes and key inflammatory cytokines. At the baseline visit, both collagen formation and degradation markers showed statistically significant weak to moderate correlations with CRP, IL-6, and the composite score of serum interferon-inducible proteins, supporting the link between immune dysregulation and fibrosis in systemic sclerosis. We also measured the same inflammatory cytokines at the 6-month visit, enabling us to investigate whether percent change in collagen neoepitopes from baseline to 6-month visit correlated with the change in the inflammatory cytokine levels during the same time period. We observed that change in collagen degradation markers showed the highest correlation with the change in the general inflammatory marker CRP, supporting previous findings where antifibrotic drugs were used in clinical trials, showing that antifibrotic drugs lead to an initial transient increase in CRP, supporting the notion that breakdown of collagen might actually induce initially an general inflammatory marker such as CRP, which is produced by the liver. In contrast, the change in the serum interferon score showed the highest correlation with the change in the collagen formation biomarkers, PRO-C3 and PRO-C6, which was not observed with the change in CRP or IL-6. This finding provides additional evidence for the profibrotic effect of interferon pathway in systemic sclerosis.
Thank you. Well, regretfully, it's time to end our interesting interview. I'd like to thank you both for your really eloquent explanation of the findings of your paper. To our viewers and listeners, please read the article, Association of Type 3 and Type 6 Collagen Neoepitopes with Disease Severity and Systemic Sclerosis, which is available in the journal's website at jroom.org and is in the May 2026 print edition of the journal. Thank you for joining us, and we hope you will tune in next month for another featured article of particular interest from the Journal of Rheumatology. We would love to hear your comments on X at jroom or via email at manuscripts@jroom.com. Thank you.